Hi everyone, welcome to my YouTube channel where we discuss interesting math problems as well as puzzle problems. Today, we are going to take a look at this question. This question actually comes from the International Junior Math Olympiad. It is question 30 at the end of the paper, so it's one of the hardest questions, I assume, and is intended for students who are in the 6th grade, so around 12 years old. Let's take a look at the question together. Feel free to pause the video at any point if you wish to solve the problem yourself before listening to my approach and my solution. So here's the question. Let us call the whole number lucky if its digit can be divided into two groups so that the sum of the digits in each group is the same. For example, 34,175 is lucky because 3 plus 7 equals 4 plus 1 plus 5. Find the smallest 4-digit lucky number whose neighbor is also a lucky number. That is, the whole number next to it is a lucky number as well. Let's look at what we know, shall we? So, we need a 4-digit number. It must be lucky, which means we must be able to split its digit into two groups, for which the sum of digits are the same. And its neighbor must also have the same property. When I was solving this problem, my first instinct was to start small. The question looks for the smallest lucky number after all. A good trick to know when you are not sure how to approach a question is to have a bit of wishful thinking. In this case, we don't know how far along the number line the answer actually lies. Why not we try letting the 1000 units be 1, the smallest number it can be, and go from there. Does 1000 work? No, it doesn't. We can't split the digits into two even groups. Does 1001 work? Seems so. We can split the digits into 1 plus 0 and 0 plus 1. But remember that the question requires the neighbor to also be a lucky number. So before we get our hopes up, let's look at 1002. Now, it's obvious that we cannot split the digits into two categories of equal sum. So 1001 is not the answer we are looking for. We seem to be stuck at this moment. What can we do next? If we play around with a few more numbers, you'll discover that in order to be able to split the numbers into two groups of same sum, we need all the digits in the 4-digit number to add up to an even number. This makes sense. If the sum is odd, you wouldn't be able to divide it by 2 and still get an integer sum for each group. Here is a clever part of a question which requires you to think out of the box. Remember that the question asks us to look for two consecutive lucky numbers. If you calculate the sum of 4-digit numbers, you will notice that they seem to alternate between odd and even as you go along the number line. Until, we hit 9 on the units digit and has to carry over to the 10th digit. In this case, since we are adding 1 to the 10th digit and subtracting 9 from a units digit, the net impact is to subtract 8 from the sum of digits of the previous number. Since the previous number has an even digit of sum, this number should still have an even digit of sum. This doesn't guarantee that we have two consecutive lucky numbers, but now, at least, we have a fighting chance. So we can be confident that the smallest lucky number we are looking for looks something like this. We have 1 in the thousands digit, 9 in the units digit, with the rest to be determined. That's so far so good. However, remember that we still want to make our lucky number as small as possible. Why not we let the hundredths digit be 0, the smallest number it can be? Then, in order to make the sum even, we will need to make the 10th digit to be 8. So, 1089 is a lucky number. The question now, is the neighbor 1090 a lucky number? Not so much luck it seems. Now, I know it seems hard and frustrating, but don't give up. Let's try with 1 in the hundredths digit, and to balance the sum out, the 10th digit has to be 7. We already know that 1179 is a lucky number. So let's check 1180. Doesn't seem like we have much luck here either, do we? Let's proceed a bit further with 2 in the hundredths digit. Using the logic from before, we have got 1269 as our potential final answer. But we need to check 1270. Again, this doesn't work. What about 3 in the hundredths digit? We have 1359, and we need to check if its immediate neighbor, 1360, is a lucky number. Seems much more hopeful, but after playing with the numbers a bit more, you'll notice that it doesn't seem to work either. Just as we are about to give up, let's give it a final push. Let's try 1449. We need to check whether 1450 is a lucky number. And hey, it is. And that turns out to be the correct answer. Throughout this question, I demonstrated a few important tricks when it comes to tackling an unknown question. You might have no idea what you are wrestling with at the beginning. This is normal. The important thing is, don't be worried to get your hands dirty and try playing around with the question itself. And don't be afraid to make clever guesses. From the very beginning, our focus was very clear. We want to find the smallest solution. So you see me starting with 1 in the thousandth digit and with 0 in the hundredth digit before moving to larger numbers when we find that our initial guesses don't work. The second important thing was to discover the trick that we have to fix the unique digits at 9. How did we discover this? Again, by playing around with a few consecutive numbers in a row and discover the carryover anomaly. Once we discover this and fix two numbers in their place, it doesn't take too long for us to get the final answer. Finally, how did we know when to give up? We failed at 1089, 1179, 1269, and 1359. Does it mean that we continue trying each time even though our strategy keeps failing? When should we stop? We will discuss the topic of when to give up on an idea. If it is nowhere when you are solving a math problem, but this will be in future videos. I hope you enjoyed this episode, and I will see you in the next one with another interesting problem.